Okay, I'm recording. So this is geotrig lesson 24. We're going to call this day 2. And we're going to use what we started with. What we started with in the last lesson was, hey, I told you these really cool things called reference triangles. I kind of hinted at them before. And I showed you what they were, what those ratios were, and that you could take those ratios and multiply them by all the same number, and they still hold true for a 45-45-90 and a 30-60-90 triangle. So, to start this off, we are going to do exactly what we did yesterday or last time, and that was evaluate sine, cosines, and tangents of angles from the unit circle. But we're going to add the fact that we're not going to have one of them, we're going to have two of them. Which means I need you to add them together after. You're going to evaluate them separately, as we got our example here, separately, and then bring them together. So, as number 1 says, draw the reference triangles with Sohcahtoa underneath it. I'm going to pause the video and give you guys some time here. Give me the 2 reference triangles right here without looking back. Go. So, what are those 2 triangles? The 2 triangles,
45, 45, 90.
they are 45, 45, 90 and 30, 60, 90. I told you guys, when you guys do these, make sure you write them the exact same way every single time, because that way I can pick them up and turn them, move them in the order that I need them to be. What goes on the bottom leg here?
1.
So 1. What goes over here?
1.
1. And the hypotenuse?
Square root of 2.
Square root of 2.
Is it okay if I put X's in there?
You can put the X's on there, but for these exercises you do not need that. Because we're not trying to compare triangles or find a third leg necessarily. We're trying to just evaluate sines, cosine, and tangents of the trig function of 30s, 45s, 60s. The 30, 60, 90, what goes on the bottom?
1.
What goes on the hypotenuse?
2.
And what goes on the last leg?
Square root of 3.
Square root of 3. Now, I had some people in the last couple hours ask some pertinent information. They're forgetting that when I first introduced back in lesson 14, the idea of Sohcahtoa, and there's opposites and adjacents, and I told everybody to point left. Point left. And then we all pointed in different directions. It's because we all are facing slightly different ways, right? Yeah. My perspective is different than yours. So recap, if I am up here at this 30-degree angle, opposite 30 is 1. Adjacent is square root of 3. The hypotenuse is always the longest side. So be careful. That's how we're going to use opposite, adjacent, and hypotenuse. Now that we have these 2 triangles, we are going to be quite happy about it. Because to evaluate these trig functions, all I'm going to do is replace the function with its exact value. I do not want to see a calculator out today. We don't need them. I want exact answers only. Now what we need to realize is that exact answers are going to look messy. If you think about, look at this. I got 1s and square roots of 2s. I got square root of 3s, 2s, and 1s. They know that when I say find the sine, cosine, and tangent, I have to follow, I forgot to put on here, Sohcahtoa, right? And Sohcahtoa has these things. Opposite, hypotenuse. Adjacent, hypotenuse. Opposite, adjacent. What do they form every single time you use it? Why does everybody keep saying triangles? It's not triangles. Not theta.
Well, you can answer
Opposite over hypotenuse. Fractions.
Theta could be a fraction.
Theta is the angle that we are coming from. So, Guys, we're not forming triangles, we're forming fractions. So, we need to remember a few things. How do you add or subtract fractions?
Common denominator.
Need a common denominator. How do you multiply fractions? No, what? Cross,
Or simplifying the x factor.
not cross multiply, but switch it around.
Multiply across.
Multiply across.
No, cross me out.
Yep. So if I have a fraction, A, B, C, no. Cross multiply is connecting the corners. So we don't do that, we multiply across. So it would be AC times BD. So multiply across is the better notation or pronunciation of that. Okay? So make sure that we multiply across. So that's what's going to happen. When I go and say, I see cosine of 60, I'm going to take cosine of 60 out, and I'm going to replace it with its fraction, its ratio. So I'm going to play coach. All I'm doing is taking out cosine of 60 and sine of 45. Now, 60 degrees. That's the right triangle. Yes?
Yes.
So I got the right triangle, there's 60. What is cosine? It's adjacent over hypotenuse. What's the adjacent? 1. What is the adjacent side to 60? 1. The hypotenuse is 2. So guess what? This fraction is 1/2. Sine of 45. Sine of 45, I go to 45. I don't care which one you go from.
Because it's going to be 1.
It will be the same. Opposite of 45 is a 1. The hypotenuse is always square root of 2. So this becomes 1 over square root of 2.
We don't like square roots in the basement.
Okay. Now, guys, I'm going to tell you this is going to happen a lot. We have square roots in the basement, and we don't like that. So how do you get rid of square roots in the bottom?
Multiply by the square root.
What?
No, we're going to multiply the square root of 2 over the square root of 2. So this equals 1/2 plus square root of 2 over 2. We now have 1/2 plus 2 square root of 2 over 2. Now, I was saying, before I got paused here, guys, this idea that you're going to have square roots on the basement is going to happen. Because look up here. There's a square root of 2 in this triangle, in the 45, and there's a square root of 3 in the 30, 60, 91. So therefore, there's likeliness that you will end up with a square root in the denominator. Now, does everybody understand that if I don't like square roots in the denominator, that I am going to multiply by the top and bottom by the square root of 2, or the square root of 3, or the square root of 7, whatever that happens to be that square root? And you know what's going to happen every single time? Some of us, I'm hoping, can make the leap. Instead of writing 1 over the square root of 2 and showing all of this little work, can go straight to square root of 2 over 2. How cool would that be? So, what we have here is, I just have to finish it, put it together. I got my common denominator, so it becomes 1 plus square root of 2 over 2.
Yeah.
Done. Now, wait a minute, guys. I have a question for you, because this is coming up in a couple of the other hours. What's x plus x?
2x.
It's 2x. I had a number of students who wanted to make that x squared. This is gathering like terms, right?
Yes.
So if you have a cookie and another cookie, you have 2 cookies. You don't have 2 cookies squared.
That'd be nice.
What about square root of 2 plus the square root of 2?
2 square root 2.
Yes,
Let's go!
it's 2 square root 2. I do not square the square root. They're not multiplied, they're added. Be careful when gathering like terms. Okay? Next one, guys. I want us to try this on our own. Take it away, the tangent of 30 and the cosine of 45. Try to figure this one on your own. So, if I take tangent out, and I take cosine out, now again, I don't have the triangles on here. I took them out of view. But tangent of 30, what's opposite? Because it's tangent, it's opposite over adjacent. Opposite of 30? And then adjacent? Square root of 3. Cosine of 45. Adjacent of 45? Hypotenuse? Okay. So does everybody understand where those ratios came from? You have your triangles. Look at them. Make sure that you are studying the fact of what's opposite, adjacent, and hypotenuse. Now, let's fix these. I don't like square roots on the bottom, so I'm going to multiply by the square root of 3 over the square root of 3, square root of 2 over square root of 2. Leaving me with square root of 3 over 3 plus square root of 2 over 2. I hope everybody is able to do that. Guys, I have found that most of the time students can do the particular concept like switching. They're able to replace it with the appropriate ratio, but they make huge mistakes when they start to use algebra. Kids in calculus, they can take a derivative, they can take an integral, but if they have to use it by cleaning it up and throwing numbers in, solving for 0, which is algebra, they struggle. Make sure that you are fundamentally good and sound on how to work with fractions, how to combine like terms, how to square numbers, how to rationalize numbers. It'll take you far. So, do we have a common denominator?
No.
So, what is that common denominator? So I have to multiply by 2, 2, and 3 over 3. So I end up with 2 square root 3 over 6 plus 3 square root 2 over 6. Now, do I have a common denominator?
Yes.
And so what can I do? Are they like terms?
Yes.
No.
Wait, what do you mean?
Square root of 3's are not square root of 2's, and so my answer is that. Okay, guys. Actually, before we move on here, look at the progression. The progression of this page. The first ones I had you do was, let's just switch it. It ends up being nice ratios here. One of them was had rational numbers, so we fixed it. And then we just gathered it. It had nice common denominators. The second one had 2 of them not be rational, or both of them. So you had to fix it. And then, oh wait, we don't have a common denominator. Let's put it together. The third one has the same idea. Some rational things in there, irrational things in there. And we now have a 2. Oops. The 2, guys. 2 itself can be written as a fraction. What would that fraction be?
2 over 1.
2 over 1. So if we know for some reason that tangent of 30 becomes a fraction in itself, the 2 gets multiplied to the top, the 1 gets multiplied to the bottom. Okay, so tangent plus 2 tangent 30. Let's figure this out. What is the tangent of 45?
Opposite over adjacent.
It does not matter which 45 you use.
So 1 over
1 over 1, which is
1.
1. Tangent of 30. 1 over square root of 3. Again, I don't like that. Now, could I just say this is 1 plus 2 square root of 3 over 3? Are you guys at that point yet?
Yes.
Are you guys at the point where like, hey, that's 1 over square root of 3. I can fix that.
Yeah.
The 2 should go to the top, yeah? So this is really 1 plus 2 square root of 3 all over 3. Get a common denominator of 3 over 3. So my problem ends up being 3 plus 2 square root of 3 all over 3. And there's your answer. Guys, the last problem, which we're not getting to, is the exact same thing, but instead of 2, it has a square root of 6. It has a
Can you just
1 over square root of 2, so irrational number. Here,
change that right away? Why don't you do
I actually suggest you don't change this right away. Fix it. Because tangent of 60 very well could either have another square root that ends up in the bottom, so you might as well fix it all at once. Or what happens if it ends up being a square root of 2 on top? The square root of 2 on top and the bottom would cancel. So be mindful of that. I would do the substitution first, kind of clean it up before you fix things. Your homework is all of this, guys. So that would be lesson 24. Remember, our book spirals, so therefore we have 3 different pages that deal with the exact same concept. So 24, 25, and 26. So that's what? 8 problems.
Can I take a picture of that?
Have a great day.